We've all been there, right? You've written some absolutely beautiful code, you hit run, and bam, crash. That feeling of frustration is just universal. But what if I told you that debugging isn't just this annoying chore you have to get through? What if it's actually a skill you can master? Well, in this explainer, we're going to turn that panic into a powerful, methodical process.
You know the scene. It's a wall of red text, this super cryptic error message that honestly seems like it was designed to confuse you. It feels like your computer is just yelling at you in a language you don't quite understand. Your heart kind of sinks a little. Is it a typo? A logic error? Where do you even begin?
So, in that moment, what's your first move? Let's be real. For a lot of us, it's a flash of panic, maybe some frantic Googling, or just, staring at the screen hoping a miracle happens. But the pros? They don't panic. They have a playbook. And today, we're walking through that exact playbook together.
Our playbook breaks down into 3 simple but really powerful stages. First, we're going to learn to decode that scary-looking crash report. Then, we'll learn how to isolate the problem like a real detective. And finally, we'll cover the art of asking for help in a way that actually gets you the answers you need.
Okay, first up, decoding the crash. I want you to think of that error message not as a failure, but as the very first clue in our detective story. That traceback? It's basically a map that shows exactly what went wrong and where. We just need to know how to read it.
So, you're looking at this long, intimidating stack of function calls. It's so easy to get lost in it. Most people, their instinct is to start right at the top, where the program began. But that's actually the least efficient way to find the real problem.
Here's the secret, the absolute game changer. Always start at the bottom. The very last line of the traceback is the money shot. It gives you the specific error type, like an import error or a value error. From there, you read up. Each line is like a breadcrumb showing the exact path your code took. Your job is to follow those breadcrumbs back until you find the line in your code. And that's your culprit.
Okay, so now that we've figured out the type of error and the line where it happened, the next phase of our investigation begins. We need to isolate the bug from the rest of the application so we can truly understand it and, fix it.
And to do that, we need one of the most important tools in all of debugging, the minimal reproducible example. This is just a tiny little piece of code that does one thing and one thing only. It triggers your bug. Creating this forces you to strip away everything that isn't necessary, and that helps you really understand the core issue.
Now, before you even think about creating that example to share with other people, there's this really powerful sanity check you can run on your own. This is especially true when you're working with complex models. It's a technique that can literally save you hours of frustration.
This might sound a little weird, but have you ever tried this? Deliberately training your massive, complex model on just a single tiny batch of data. I know, it seems counterintuitive, right? But as a debugging technique, it's absolutely brilliant. But why?
Think about what this proves. If your model can get 100% accuracy on one tiny little batch, you've just confirmed that your architecture isn't broken and your training loop can actually execute. So if this test passes but your full training run fails, the bug is almost certainly not in your model. It's somewhere in your data pipeline. This one simple test just brilliantly narrows down the search.
But what if you've read the traceback, you've tried to isolate the problem, and you're still just stuck? Well, it's time to bring in backup, and asking for help is a skill. Doing it the right way means getting faster, more useful answers.
Just look at the difference here. It's night and day, isn't it? On the left, you've got these vague titles that just post an error. They don't really invite anyone to help. But on the right, you have clear questions. They immediately tell an expert what the problem is. In this case, that the user is trying to use a model that just isn't supported. A great title is your hook. It makes people want to click and help you out.
So let's put it all together. The perfect bug report has these 4 key ingredients. We've already covered the title and that minimal reproducible example. But you also need to state what you expected to happen. This gives people vital context. And finally, and this is a big one, you have to provide your full compute environment.
This point is so critical. A bug that happens on your machine might not happen on someone else's. And why is that? Well, it could be a different Python version, a different library version, or even different hardware. Providing your environment details completely eliminates the guesswork, and it lets other people recreate your exact situation, which of course is the first step to solving it.
And all this brings us to a really fundamental shift in perspective. Debugging isn't some kind of punishment for writing bad code. Every single developer, from the most junior person to a principal engineer, deals with bugs. The process of systematically finding, isolating, and fixing them is what deepens your understanding and makes you a more skilled, more resilient developer.
So what if the next time you see that wall of red text, you don't feel that panic, but instead, you feel a sense of curiosity? What if you see every single bug not as a roadblock, but as an opportunity? An opportunity to learn something new, to sharpen your detective skills, and maybe even to help the next person who runs into the very same problem. Now that's the shift from developer to pro.